Today we're going to change things up a little bit, and instead of having you read what I want to cover today, I wanted to talk to you about what we've done up to this point in the chapter and review a little bit with you and then show you something new that we can do with the information. I recommend that you pause this for a moment so that you can go and get something to take notes on. This will help kind of pull it all together for you, and if I write it on the screen for you and you can see it in the video, then it's probably something that you should have and that you're keeping in your notes. So go grab some paper and pencil, and I recommend you also have a periodic table in front of you, and then come back. Okay, are you ready to go? I'm going to start by doing a little review of the 3 subatomic particles, and I'm going to start with the proton. And you answer these questions in your mind as I go through them. Where is the proton found? It's found in the nucleus. And what is its charge? It is positively charged. And what is its mass? It's 1 AMU. And we'll come back to what its function is in a little bit. Let's do the other ones first. So we have the neutron. The neutron also is in the nucleus. It is neutral. And ask yourself, what's the mass of a neutron? Hopefully you said 1 AMU. Now that's important because it's the total of all of the protons in the nucleus and all of the neutrons in the nucleus that give an atom its mass. So if I have 7 protons and 7 neutrons, then that means I have a mass of 14 AMU in the nucleus. All you have to do is add the number of protons plus the number of neutrons. In fact, you should write that down. The number of protons plus the number of neutrons is equal to the atomic mass. All right, now let's go back and we'll talk about, let me get rid of this really fast, and now let's go back and talk about the electrons very quickly. The electron is found where? It's found outside the nucleus in the electron clouds, and that's just the area where you're apt to find the electrons outside the nucleus. Electron is negative. And we say that it essentially has no mass. It's so small, it's virtually massless, and sometimes it doesn't even act like stuff. It acts like energy, so it's really easy to say it is massless. All right, now that's just a real quick review of them, but the most important thing right now that I want you to think about is what is the function and what does it do to the atom itself, and changing it gives me what? So for a proton, the function of the proton is that it gives the atom identity. The number of protons that I have is going to be the same as the atomic number on your periodic table. So for example, if I look at magnesium, magnesium is element number 12. Element number 12 means that it has 12 protons. It's the protons that determine the number of protons that determine what the element is. So it gives the atom its identity. If I change the number of protons, and that's the symbol I use for number. I know you guys are used to that as hashtag, but originally it was meant as number, and that's how I'm going to use it. If you change the number of protons, you get a new element or a different element. So if you look on your periodic table, if I were able, which I'm not, it's a nuclear event if I do this, if I add another proton to my magnesium atom, I would end up getting aluminum. So if I add a proton to this, then I would have 13 protons, and now I'd have aluminum. So the job of the proton is to give the element its identity. If I change the number of protons, then I'm going to be changing what it is. The neutron gives stability to the atom. If I don't have enough, the atom actually falls apart. That's not a good thing. So it gives stability to the atom and it adds mass. Of all of the subatomic particles, it's the one that is a little less important. I hesitate to say that, but you can play with the number of neutrons and it doesn't change things dramatically. But if you change the number of protons, that's a big deal. And changing the number of electrons is what gives us all of the variety of things we have, and we'll talk about that. So if I change the number of neutrons, I get an isotope. Now let me give you an example of that. And this should all be review. We've talked about this in the reading that you've done. So this is all review. Hopefully this is familiar because you've done your reading faithfully. If you change the number of neutrons, you get an isotope. And if you remember, the definition of an isotope is it's a set of atoms that have the same atomic number but different atomic mass. So for example, let's say that I have aluminum. Aluminum is definitely going to have 13 protons. It has to have 13 protons, but it could have 13 neutrons or it could have 14 neutrons. These would be isotopes of each other. The mass of this would be 26. The mass of this would be 27, but they're all aluminum. Same element because you have the same number of protons, but different number of neutrons, so you have a different atomic mass. And isotopes all pretty much behave the same. If I have a bunch of aluminum atoms that are a mass of 26 and another bunch that are a mass of 27, I'm not really going to be able to tell the difference between them. Different atomic mass, same atomic number is an isotope. And then finally, electrons. The function of the electron is to provide a place for bonding to occur. And that's what gives us all of the different compounds that we have. Provides a place for bonding. And of all of the subatomic particles, let me write this out here real quick. Of all the subatomic particles, this is the one that comes and goes most easily. It leaves an atom as fast as it wants to, and it comes back again. I like to call the electrons the party animal of the atomic world. They're very social. They decide, I'm going to go visit another atom, and they go visit another atom. And other atoms come in, and they invite their friends, and they do that all for a specific reason, but they come and go all the time. And when they leave, if I change the number, then I'm going to get what's called an ion. And we talked about that. You get an ion for that. And we talked about that. If I lose electrons, and I'm going to start a new page here. If I lose electrons, then I end up with more protons than electrons, so I have a positive charge. Now, you've not gone into that yet in your reading, but you will. So I'm just introducing this piece to you now. And that's called a cation. And a way that you can remember a cation is that it is positive. Do you hear the word paw in there? It's positive. If it gains electrons, that means it's gaining more negative charges. It's going to be negative, and it's called an anion. Now let's talk about what this looks like in terms of isotopic notation and what you were playing with the Build an Atom website that I sent you to on Friday. If you have not done that, you absolutely need to do that. Let me give you an example of this. Let's say that I have aluminum. Please look at aluminum on your periodic table. In fact, I'm going to back up a little bit. I'm not even going to do it that way. Let's start doing it this way instead. I'm not going to tell you what element I have, but I'm going to give you protons, neutrons, and electrons. And it's what we did before. You found the protons, neutrons, and electrons for the elements that I gave you. Now I'm going to give you the protons, neutrons, and electrons, and you tell me everything you can about that element. So let's say that I tell you I have 12 protons, 13 neutrons, and 12 electrons. Well, I've already written electron there. I don't need to do that again. This is what isotopic notation looks like. First, I go to my number of protons and I say, what element is this going to be? And when I look at my periodic table, I see that element number 12 is magnesium. And so I'm going to write magnesium right here. And isotopic notation means that I put the number of the protons, or the atomic number, down there, and up here I'm going to put the atomic mass. The atomic mass comes from adding, remember we said that in the last page, that the atomic mass comes from adding the protons and adding the neutrons. And so I'm going to get 25. Now I want you to look at the periodic table. Is that the number that the periodic table gave you? The answer to that is no. Periodic table says that typically it's going to be about 24. That means I have an isotope. Same atomic number, but different atomic mass, and that's perfectly fine. That's perfectly fine. Now this is going to be the number of electrons, and if my protons and my neutrons are the same, then I have no charge at all to write here. So I'm not going to put anything there. But if I were going to put something there, it would go in that spot. So for isotopic notation, magnesium would look like this. Magnesium, 12, and 25. Again, I have an isotope of magnesium. It's not what you would see directly on the periodic table. It's a variation of that, but it's still magnesium. Right, the next one I'd like to do is 16, 17, and 16. First thing you do is what? That's right. You go to the periodic table and you say, what element is element number 16? I look for it and I find that it is sulfur. So I put the S there and I put a 16 right there. Do I put 17 above it? No. Remember that you add these two. 16 plus 17 is going to give me 33. Again, when you look at the periodic table, the rounded mass for sulfur is normally 32. So you have an isotope. Now I compare these two. If they are the same, that means it's a neutral atom. I have as many positives as I have negatives. If I have an equal number of positives and negatives, they cancel each other out, and my atom is neutral, so I don't put anything there. Now let's try this one. 13, 14, and 13. I'd like you to pause the video and try this one on your own and see what you get. Okay, hopefully what you found was that because it's element number 13, it's aluminum. And you always put the atomic number down here. The mass is the sum of these two, 27. These two are the same, and so my positives balance out my negatives, and it's neutral. So for the first one, magnesium would look like this. I'm trying to put a box around it. It's not working here. Magnesium would look like this. The sulfur would look like this. And the aluminum looks like this. Okay, now we're going to try one that has a different number of electrons so that you can practice that as well. So now I'm going to give you 12, 12, and 10. All right, step number 1. Find the element. And again, you may want to write this stuff down. So I look for element number 12, and I think I chose the wrong one. I'm sorry, let's erase that, because that's going to be, actually no, that is the one I wanted to do, I apologize. 12, 12, and 10. And we already did this one, it was sulfur, so I found the element. My element is sulfur. The next thing I do is I write the atomic number in the bottom left. So I'm going to put 12 here. And then the third thing I'm going to do is I'm going to add the protons plus the neutrons to get the atomic mass. So this time it's the normal version of magnesium. I'm sorry, I said sulfur, but it's magnesium. Were you sitting there saying, Mrs. Warner, you're not doing that right. You're right. I messed up. It's magnesium. And this should be 24 up here. Now the last thing I'm going to do is I'm going to compare my protons and my electrons. In this case, I have more protons than electrons. In other words, I have more positive charges than I have negative charges. So I know that my ion is going to be a positive ion. Now I have to ask myself, positive by how much? How many more protons than electrons do I have? I have 12 protons and 10 electrons. I have 2 more protons than electrons, so I'm going to get a positive 2 charge. Does that make sense? Let's try another one. 4, 5, and 2. First thing I do is I find the element that it is, and I'm going to write it down. Element number 4 is beryllium. Next thing I do, I write the atomic number at the bottom left, so I'm going to have a 4 here, and then I add the protons and the neutrons. That's going to be 4 plus 5 is 9, and I should have written in there, please write in there, that's the atomic mass that you write at the top left. Write that in. It's the atomic mass that you write at the top left. The next thing I'm going to do is compare my protons and electrons. Again, I have more protons than I do electrons. So since I have more of the positive charges, it's going to be a plus 2. Because I have 2 more protons than electrons. Okay, let's try another one. Let's say that I have 8, 8, and 10. I look at my periodic table. Element number 8 is oxygen, so I put a little 8 here. I add my protons and my neutrons to get the atomic mass, and that's 16. I look at my protons and my electrons, and because they're not the same number, I do have to write something in this upper right area. I ask myself, what is there more of? Are there more protons or are there more electrons? Obviously, you can see that there are more electrons. Electrons are negative, so I know that my overall charge is going to be a negative charge. Now I have to identify negative by how much. There are 2 more electrons than there are protons, so it's going to be a negative 2 charge. Does that make sense? Right, now we've dealt with some fairly easy ones, and I'm going to give you a couple of harder ones. I'll give you one hard one and see how we're doing with that. So we're going to do, let's try that again. We're going to do protons, neutrons, and electrons. And for my protons, I have 35. For my neutrons, I have 45. And for my electrons, I have 36. I'm going to look at my periodic table to see what element it is. And I believe it is, let me check this real quick, but I believe that it's bromine. I'm correct. So I'm going to write Br. I remember to put my 35 down here, and remember I'm not going to put 45. I have to add those two to get my atomic mass, and my atomic mass is going to be 80. Now I look at these two numbers. If they're the same, I just walk away because that means it's neutral and I don't have to do anything. But they're not the same. This is bigger. My electrons are bigger than my protons. So since my negatives are bigger than my positives, I'm going to have a negative charge here. How much more negative? I have 1 more negative, so it's a negative 1 charge. Okay, how you doing with that? Does that make sense? Should we try one more just to make sure you're understanding it? By the way, this is called an ion because it has a charge to it. Whether it's positive or negative, it's called an ion. Let's try this one. 7, 7, and 10. Look at the periodic table. Element number 7 is nitrogen, and I put the 7 here. I add these two together to get the atomic mass, and it's 14. I look at these and I say, are they the same number? If it's the same number, I walk away. It's not the same number, so I'm going to have to identify which one has more. My electrons have more, so I'm going to be negative because electrons are negative. How many more electrons than protons do I have? I have 3 more. And that's it. This is called isotopic notation, and it tells me everything I want to know about that particular atom. Another way that you will sometimes see these things written would be bromine dash 80. Now, that's all it tells you is bromine dash 80. Here's the thing. If it's bromine, then you already know the atomic number. The atomic number of bromine is 35. And the 80 tells you this is the version of bromine that I'm dealing with. Bromine that has 35 protons and 45 neutrons. So writing it this way is just a faster way of saying it, and this number is the atomic mass. It's not the atomic number, it's the atomic mass. Because really, when you think about it, you already know what the atomic number of bromine is. You can get that right off the periodic table. It will always be 35, but the mass will change, so that's something they always have to give you. This is isotopic notation, and this is the way you're going to do your homework, so that it should look something like this when you're done. Silicon, 14, 28, and if there's a charge there, then you would